Okay, this is number 2 on the 4.4a practice quiz. And a rectangular plot of farmland will be bounded on one side by a river and the other 3 sides by chain link fence with 2,000 feet of fence. What is the largest area you can enclose? And what are the dimensions? Okay, so we draw a sketch over here. This is the river and this is our rectangle, except we only have to worry about 3 sides. So this would be a width. This is going to be the same width and the length. And we know the perimeter, the amount of fencing we have altogether, the amount of fencing we have adds up to be, well, the perimeter would equal length plus 2W. But how much fence do we have? We have 2,000 feet of fencing. So that's going to equal 2,000 feet. Now that's actually our constraint. This is our secondary equation, our constraint. Or the secondary equation. Our primary equation, what we want to do is we want to find out, okay, what is the largest area we can enclose and what dimensions would be the enclosed area. So we want to maximize the area, and area is just length times width. So that's our primary function, or our primary equation, or sometimes called the objective equation. But we can't take the derivative of this. So what we're going to do is take the derivative. We can't do that because it's in 2 unknowns. So we have to use our constraint over here to reduce that. So we can solve this. Now it's going to be a little bit easier to, I don't want to divide by 2, so I'll just solve for L. L will equal 2,000 minus 2W. If I solve for W, I'd have L over 2. I have a fraction, so that's a little messy. So now I'm going to rewrite this area equation over here. And I have L, so instead of writing L, I'm going to write the 2,000 minus 2W times W. Now that's going to give me my area as a function of W now. So now area as a function of W equals 2,000 W minus 2W squared. And that's what I want to take the derivative of. So area prime of W would equal 2,000 minus 4W. And we want to see where that is equal to 0 or undefined. It's not undefined, so we just set it equal to 0. And then we could add, so 2,000 equals 4W. And if I divide both sides by 4, I get W equals 500. Now I can check that. The first derivative test, I could use A prime. And if I put, and this is 500. So I put 100 in here, this is going to be positive. If I put 1,000 in here, that's going to be definitely negative. So my actual area is going from positive to negative, so it is a relative maximum. That's my area as a function of x. Okay, so that's easy to check. So that's my width. How do I find the length? Well, the length is equal to, right up here, 2,000 minus 2W is L, right? So L equals 2,000 minus 2 times 500, which is 2,000 minus 500, which is 1,000. So those are my dimensions, and that's actually the second part. That's B. The dimensions, and I think these are going to be in feet. So it'd be 1,000 feet by 500 feet. And A, the maximum area, well, I just multiply that. So if I take 1,000 times 500, I got a 5, and I got 1, 2, 3, 4, 5 zeros. So that's going to be 500, and that's going to be feet squared. Oops, sorry. Okay. So those are your dimensions, and that's your maximum area. Okay.